I think we'll get started. So thank you guys for coming to this session. My name is Michael. I'm the founder and CEO of Bobyard. And today we're going to do, well, I was asked to talk about AI in general. And so I promise not to do much sales here. I really want to, I think the purpose is to give you guys some intuition on how AI as a technology actually works and what it might be good at, what it might be bad at, and for you guys to go off and make your decisions on it for yourselves. So quickly we'll go over Bobyard and sort of the story there, and then the main contents about AI, and then at the very end I'll do a quick demo. So that's me. The company's name is Bobyard, and it's named after Bob the Builder. And so as a very young little kid, that's me as Bob the Builder on Halloween, I think. And so I grew up in the Bay, San Francisco Bay Area in California, and I've always loved building things with my hands and eventually software. And so I got to Stanford and studied CS and math there, really like the behind the scenes math of how machine learning models work. And a lot of it really is just math. And Bobyard, we're about 3 years old. We basically train AI models to read construction drawings and help you guys do takeoffs and estimates. And so, when compared to like a traditional takeoff tool, we basically train AI models to use normal, on-screen takeoff tools for you. I think we're very, blessed to have such an amazing team. It's literally a team of PhDs from like Stanford, Virginia Tech, and Princeton and whatnot. Realistically, if you have a PhD from Virginia Tech, you can have an offer from any company you want. We do something crazy like we double revenue every quarter right now. It's a pretty exponential growth curve. We've tripled headcount since the start of the year, and I think we'll be actually more than 5x headcount this year, probably a few times more than that. Because of all the growth, we're also very lucky to have very good venture backing. So Pear, Primary, and ABC, they're pretty iconic investors. You might have heard of DoorDash and Dropbox and whatnot. More recently, so last year, we announced our Series A. And I think that was actually, looking back, that was probably a special round. Maybe we should have done more press about it. But we raised $35 million in a Series A. And as far as I can tell, like that's probably the biggest round anybody's ever raised in construction software. It's not every day that like Joe Lonsdale, who's the founder of ABC, tells you he wants to be on your board. I think it's a cool sign that not only is sort of mainstream Silicon Valley venture capital finally like investing in AI startups and construction, but like in general, I think they actually see finally for the first time the opportunity there is in construction as a whole, as a vertical to innovate in. I think it was a pretty cool moment for not just Bobyard, but also for the whole industry. But okay, that's all I'll talk about Bobyard for today. If you want to hear more about us, like our team, there's Molly and Jared back there. They're more than happy to talk more about what we do and whatnot. The actual content for today is about AI. To reiterate, so the point is to try to give you guys an intuition for actually how this works. I think people say AI all the time. It's like, okay, how does it actually work? Can I have an intuition for it? I'll explain some history and background of it and where it came to be. First is just like, what is artificial intelligence, AI? I think very, very simply, it's just anything that mimics human decision-making and intelligence. It's just intelligence that is artificial. We've actually had this for a long time. On your phone, you've had a AI bot that plays chess better than you for many, many years. And the first checkers AI bots came out in like 1960, 70 or so. And it's like, they've been able to beat humans for a long time. If you go on Google Maps and you like type in an address and type how do you get to this hotel, like that's also a clever algorithm that's like trying to decide which way to go. But there are a lot of, I guess, like buzzwords that people throw around a lot. There's AI, machine learning, deep learning, all these different things. So I'll quickly describe the universe of these things first. Overall is algorithms. Algorithm is just anything that does any decision making. So any software has a bunch of algorithms in it. Then artificial intelligence is just anything that mimics intelligence. And then machine learning is a very special type of intelligence. And the way this works is, let's go back to that chess bot. The chess bots have been very good for a very long time. And the way it used to work is you would program the model to try every possible move to see what the optimal move is and place the next best move. However, if you were to change the rules of chess, like add a new piece or change one of the pieces to do something different, it would not work anymore because there's a whole new world of moves to try. And so like every time you change rules, every time you have to reprogram the model to do a whole new set of things. And so this is a huge pain. It doesn't work on things it's never seen before. And then the key is like, what if we change the rules of chess and the model could still learn how to play? Because if you gave chess to a human learned it, and you change the rules, the human can pick it up again. And it's like, oh, a slight change in the strategy. And so that's the breakthrough for machine learning. The point is to train models to do things it's never seen before. The example that people start with is cats and dogs and sort of image recognition. Like this is like early 2010 or something. YouTube came up with an algorithm that could differentiate an image, and it could tell you if it was a cat or a dog, and it was like really accurate. And I was like, this is the ground. this is an amazing accomplishment. It's the end of the world. AI is going to take our jobs, and it could recognize cats and dogs. It was a huge breakthrough. And the key insight there was like before machine learning, you would have to hard code certain things for the model to look for. Okay, if it has pointy ears, it's more likely to be a cat, maybe a certain type of tail, whatever features are hard coded. But the key for machine learning is that you never teach it what to look for, you just give it the answers. This is defined as model training. You give these images of cats and dogs to a model, and in the beginning, it doesn't know anything. It'll just randomly guess 50-50, cat, dog, cat, dog. And then instead of telling it, these are things to look for in order to say it's a cat, you just say you're wrong or you're right, this is indeed a cat or this is actually a dog. And every time you give it feedback, either correct or false, it'll incorporate that feedback and try to understand on its own what makes up the concept of a cat or what makes up the concept of a dog. And then eventually, after literally millions, sometimes billions and trillions of examples, it starts to understand on its own how this works. Going back to the previous slide, the final circle there is called deep learning. And deep learning is the same as machine learning, it's just the models get extra big. And that's really all it is. Then you might have another question, which is like, what's behind the recent AI boom? Like, why do you hear about it now? And why am I here? Why is every vendor AI now? And it wasn't the case like 5 years ago. And YouTube came up with, AlexNet and all these different things, and ImageNet came out a long time ago. There's a few different things. This is a picture of Moore's Law. Moore's Law describes that the density of your chips double every year or two. And so this is a graph of like the density of the chips and whatnot. And it's a log scale, and so it's a roughly linear curve, which means that if you don't log it, it's exponential growth. Funny things happen when you exponentially grow something. So there are three key pillars of growth for AI. Number one is data. Number two is algorithms. Number three is sort of compute. The first one, data. Without the internet, you could not have trained these massive models. ChatGPT is an answering machine, and there are forums online like Quora and Reddit, which just happens to be answer question format. And so, it turns out to be a really natural training. Algorithms. In reality, actually, there's not that many changes in architecture and algorithms in the past couple of years. It's mainly just like people found this breakthrough, which is if you just have exponentially bigger models, it just performs better and better. And only in the past couple of years could we train these massive models. And so the third pillar is compute. And you'll notice like NVIDIA GPUs literally double in speed. Every new launch is like several times faster than the previous one. And now you can have like orders of magnitude bigger models that inference on new things. Now, sort of challenges and sort of what models are good at, what models are bad at. I think that the framework to use here that Bobyard uses is, when we look at AI models internally, like we also use AI models for ourselves, is that AI models are middle to middle and humans are end to end. Humans, you can tell them like, they can define their own task, go execute their task, and then like evaluate themselves and feel good about themselves afterwards. The model can't. The models are good at middle to middle, as in they can't define their own task, and they are very bad at double checking their own work. And so I think a key insight for AI is that the more narrow the scope is for your work, the more accurate you can expect the model to be. Like a general model that's trained for everything possible in the world is okay at everything, but not great at anything in particular. And then you have very specific models that are trained just for one specific thing, and that's all it's supposed to be good at, and it can be very good at that and ignore everything else. Naturally, there's a concept called hallucination. And I think going back to the cat and dog example, it's inherently still a guess. Like after 1 trillion examples of cats and dogs, and you slapping the model around in the face being like, this is wrong, it's going to be very confident, but not 100% correct. It's going to say, I'm 99% sure this is a cat, and there's a 1% chance this is a dog. And inherently, it's still a guess. And it's guessing the label for this image. And ChatGPT is guessing the next word or the next paragraph. And so it's inherently a guess. And when it gets wrong, it's called hallucination. When it gets right, they call it AI, and the stock goes up. In general, models we consider to be middle to middle and humans end to end. And sort of the more work you do to define a narrow task for the model, the better it can perform. Models, once you define a narrow workflow, it's more than happy to constantly do it 24/7, millions of times back to back, like never taking a break. And you can spin up new instances of the model infinitely, basically. And so, once you get it to, for example, Bobyard, we do takeoffs. So like once you train a model to count plants, once it's down, once it's good and locks it down, it's like, okay, I'll happily count plants, tens of thousands of plants, all day, every day, electrical receptacles, whatever it might be. And I think one other key thing is like in the media, you'll hear two major narratives about AI. The first narrative is AI will take your jobs and it'll be the end of the world. And the second narrative is it's actually all a bubble and NVIDIA's going to crash one day. And you'll hear both narratives simultaneously in the news. And I think upon inspection, you realize that both can't be true at the same time. You can't take away all the jobs and also have a bubble at the same time. Like and so the truth is somewhere in between. And there's like tens of billions, hundreds of billions of dollars of investments on sort of on the line here. And so people are incentivized in weird ways for the media. In general, the truth is somewhere in between. And I think a good example of this in previous history is a model called AlphaFold from Google. Not sure if you guys know this model. The team that built this won like a Nobel Prize recently, I think last year. And the point of this model is it predicts how proteins will fold way faster than how you would do it normally. So like normally before AlphaFold, you'd like spend weeks and weeks doing an experiment to see how it would go. AlphaFold just like computes it for you and is done. This did not result in a massive layoff in like biological and chemistry researchers. It resulted in like way more need for researchers, and now we can just do drug discovery faster. I think it's a good example of like, it doesn't take away sort of the thing that only humans can do, and in fact, like your business is optimally run when everybody in your company is only doing things that only they can do at all times, sort of a state of optimal, like maximum leverage. And maybe it's not the case that you have to be in a wet lab for 4 months to do this one protein experiment. You can just run an experiment with AlphaFold. And so I think a cool way to think about AI is it's a way to increase leverage for your employees. Same with how we think about Bobyard. Like we increase the leverage of each of your estimators. Where to look and sort of like how to evaluate different software tools and AI tools. I think everybody in the world is screaming AI at you, and there's like a bunch of ads and whatnot, a bunch of different products. We sell to very different companies all the time. We sell to huge companies with like hundreds of millions in top line, billion in top line, or very small sort of like mid-market companies as well. And I think that the most successful companies that we see are the ones that think like enterprise customers. And what I mean by that is if I go to a huge commercial subcontractor that's like a few hundred mil top line, they'll be like, okay, thank you for all the talk. Give me the product. I'll do a bake-off with 5 other products. I'll A/B test them. I'll like quantify the actual returns and how much faster it actually is. Like you can tell me it's 50% faster, that's great, but like how much faster is it for me in reality? And then they go and A/B test and they build this like financial model for returns and they calculate the ROI for the product and whatnot, and they make a decision that way. But I also see the opposite, which is like there are smaller companies that sort of like go off of like vibes. It's like, this product feels like it's this valuable, therefore I'll pay this much for it. and your product is so expensive, it doesn't feel like it's worth that much, or it feels like it's not as valuable. And I think maybe the actual thing to say here is like, if you're a decision maker in a company, I'm the CEO of Bobyard, and I sort of owe it to the company to make good decisions for the company. And like if you choose not to use AI because you didn't bother learning about AI for this one product, I think it's a very different state than if you learned about the technology and did the evaluation and decided it was not good for your business. And that's totally fair. But like sort of as a decision maker in your business, you sort of owe it to your business and the other employees in your company to learn about the new headwinds and the trends and tailwinds and whatnot in the general environment. And so I think diligence is the key. And sort of like if any software provider doesn't want to help you with a bake-off, that's not good. They should help you with a bake-off and help you do the ROI calculations. The last little bit, I'll do a quick demo on Bobyard. We'll play a short video of like 2 minutes or so. And just like verbally context here is like Bobyard, we're a very modern takeoff and estimate suite. You can do full takeoff and estimates here and create your bids and proposals. And we've embedded AI models throughout to help you do takeoffs. So like measurements, counting, length, area, text, all these different things that you can extract from blueprints. And we'll do a quick video on electrical, which is a sneak peek at our new model that we're launching in the next few weeks.
Welcome to Bobyard, the most powerful AI takeoff engine on the market. This is the Bobyard platform. Start your takeoff by clicking Create a Project. Upload a file. Let's count every receptacle here. Start by opening the Legend Manager. Run the legend count on the area you specify. The model just identified 552 receptacles in under a minute. Let's quickly give it a glance. Bobyard's confidence rating system allows you to easily identify edge cases. Go through the review process to confirm accuracy. Upon completion of the review, finish your takeoff. As you can see, Bobyard has quickly and accurately counted the entire page. No more counting by hand. To identify the circuits in your blueprint, start by opening the AI workbench. Select Electrical and click Circuitry. Bobyard will find all the wires immediately. You can select between circuitry lines, direct lines, and Manhattan lines, and click to add them to your takeoff. Now, let's say you want to route a panel to specific devices on a circuit. To start, go back into the electrical section of the AI workbench and click Circuit Routing. Here you can select your panels, device positions, any obstacles, and preferred paths.
One last thing I'll say about just the demo here. The way you think about this is, so I mentioned these 4 things earlier. I think they're we call them the primitives. So counting, measure length, measure area, and text. Those are the 4 primitive things that can exist on a 2D drawing. And sort of everything is built on top of that. And so we have models that do each of these 4 primitives really well. And then the next step is to infer meaning by combining multiple of these primitives together. So for example, it's not enough just to count the receptacles. It's like there's a text next to it saying this is circuit number 12, panel A. Like you need to read the text, associate the 2, and understand what's going on. And here it's showing wiring. We literally do the wiring for you at this point. And it's smart enough to know, oh, this conduit has too many turns, you should change it. Or there's too many wires in this conduit, it's going to get too hot, you should change it, etc. We can literally read the schedules and the codes and give you these sort of like recommendations and whatnot. I think I'll stop there. Like happy to answer questions about Bobyard, but really just I think in general about AI and whatnot. I think if you want to learn more about AI, or if you want to learn more about like the Bobyard team, we're happy to answer questions about what we do and the product. We have a booth. Maybe you've seen that already as well.
All right, appreciate it.
Well, thank you guys.
Michael, thank you.